नमस्कार विद्यार्थी मित्रांनो. Today we will solve some more problems on section formula. In the last lecture also we were solving problems which are based on section formula. So these problems are from exercise 5.2. First question is, find the position vector of point R. Find the position vector of point R which divides the line joining the points P and Q, whose position vectors are 2i minus j plus 3k and minus 5i plus 2j minus 5k in the ratio 3:2. There are two parts. In first part division is internal, in second part division is external. So point divides the join of P and Q in the ratio 3:2 internally. Then what is it? Position vector. After getting position vector we can find coordinates also. So here this is P bar. Here it is denoted by P bar. It is position vector of P. This is Q bar, position vector of Q. Now if R bar divide PQ internally in the ratio 3:2, then by section formula R bar is equal to 3Q bar plus 2P bar upon 3 plus 2. MB bar plus NA bar upon M plus N. This is the section formula. MB bar plus NA bar upon M plus N. So here M is to N is 3:2 and P and Q have position vectors P bar and Q bar. Now we put the values of Q bar and P bar here and simplify and get the position vector of point R. So here plus sign is used in formula. So this is for internal division. And for external division everything will be same, only this sign will change. फक्त हे चिन्ह बदलणार आहे. इथे मायनस साइन घेतलं की तर 3 minus 2 येणार, तो डिनॉमिनेटर 1 होणार. दॅट इज फॉर एक्सटर्नल डिव्हिजन. हिअर आर द कॅल्क्युलेशन्स. आफ्टर गेटिंग पोझिशन वेक्टर वी कॅन फाइंड कोऑर्डिनेट्स आल्सो. सो हिअर आय हॅव रिटन कोऑर्डिनेट्स आल्सो. Now here for external division, if division is external then only change is here in sign. इथे प्लस साइन होतं ते मायनस झालेलं आहे आणि तो डिफरन्स चुकला नाही, तर परत 5च लिहिला गेलेला आहे ह्या स्टेपमध्ये. इन दिस स्टेप आय हॅव मेड मिस्टेक. सो दिस 5 शुड नॉट बी देअर. 3 minus 2, 3 minus 2 is 1. 3 minus 2 is 1. So this minus 19i plus 8j minus 21k is the position vector of the point which divides PQ externally in the ratio 3:2. And if we want coordinates we can write coordinates also. Minus 19, 8, minus 21 are coordinates of that point. Okay, so this is one application of section formula. Now next application of section formula is find the position vector of midpoint M joining points L and M. So here we have to use midpoint formula. You can use section formula with the ratio 1:1. Midpoint divides segment in the ratio 1:1. And if you want to use direct midpoint formula, it is A bar plus B bar upon 2. The position vector of midpoint of segment AB is A bar plus B bar upon 2. Here it is L bar plus N bar upon 2. I have written L bar, N bar from coordinates of L and N. Add them and divide by 2. That will give you the position vector of the midpoint. So this 6i minus j plus 5k is the position vector of the midpoint of segment LN. मी कॅल्क्युलेशन पार्ट जो आहे तो तुम्हाला वाचून दाखवत नाहीये, ते तुम्ही स्वतः वाचू शकता. खरं तर नुसतं वाचण्यापेक्षा हे कॅल्क्युलेशन्स तुम्ही करणं अपेक्षित आहे. सो यू शुड स्टॉप दिस व्हिडिओ, यू शुड पॉज दिस व्हिडिओ अँड टेक अ नोटबुक अँड do your calculation your own and then check your answer, compare your answer with my answer. So these are coordinates of midpoint. I always write coordinates also after getting position vector. Now third problem is, if the points A, B, C are collinear. If points A, B, C and collinear, then find. Now what to find? What you will find? We can find values of P and Q. We can find the ratio in which P divides C divides AB, A divides BC, B divides AC. Now here we are asked to find values of P and Q also, and the ratio in which point C divides AB. Now here we observe that if we see the Z coordinates, here Z coordinate of first point is not given. We know only Z coordinates of second point B and third point. If we look at the Y coordinate of second point is not given. X coordinate of all 3 points is given. That means it is possible to find the ratio in which each of the point divide the segment joining other two. Now here I will use vector method. So first I will write position vectors of A, B and C using their coordinates. So here are position vectors of A, B and C. After writing position vector, we want to find the ratio in which C divides AB. So let that ratio be k is to 1. Let that ratio be k is to 1. Now I use section formula, and using section formula I write position vector of C, that is mb bar plus na bar upon m plus n is the formula. Here ratio is k is to 1, so kb bar plus 1a bar upon k plus 1. And I compare this vector with actual position vector of C, and equating coefficient I can get value of k. So these are the calculation, these are the steps. I will not read it step by step. Finally we compare them, and comparing them we get value of k. So from this first equation, by equating coefficients of I, here coefficient of I is minus k plus 3, and this side coefficient of I is minus 3k plus 1. So equating them we get value of k is equal to minus 3, and if we put that value here we can get value of p. This equation will give you value of q after writing this value k is equal to minus 3. Okay, so this is how to find ratio and values of unknowns p and q using those equations. Now next application of section formula is, the position vector of points A and B are 6a bar plus 2b bar and a bar minus 3a bar. These are position vectors of points A and B. If point C divides AB in the ratio 3:2, then show that the position vector of C is 3a bar minus b bar. So answer is also given here. We have to use section formula, and using section formula we have to find position vector of C. Okay, so when the type of division is not mentioned, whether it is internal or external, we can assume that the division is internal division. So here is the formula for section formula: mb bar plus na bar upon m plus n. But in place of b bar I have used position vector of b, and position vector of b is given. It is not only b bar, it is a bar minus 3b bar. So I have written here a bar minus 3b bar. Na bar means in place of a bar I have used position vector of a bar. So using these position vectors and simplifying them, we can show that the position vector of C we get, after simplification of this, we get 3a bar minus b bar. So this is 6 to the 12a bar plus 3a bar, that is 15a bar. 15 divided by 5 is 5, and this 2 to the 4 4 minus 9 is minus 5 b bar. It is divided by 5 and that gives minus b bar. So it was simple application, straight application of section formula for internal division. Now this is little bit lengthy and geometrical problem. Prove that the line segment joining midpoints of adjacent sides of a quadrilateral form a parallelogram. What is the problem? Prove that the line segments joining midpoints of adjacent sides of a quadrilateral form a parallelogram. Let me explain what this problem says. Problem says if we have any type of quadrilateral, and if we take midpoints of its sides, suppose these are midpoints of its sides, if we join these midpoints, then a quadrilateral is obtained. This problem says that this green colored quadrilateral, prove that this green color quadrilateral is always a parallelogram. You can start with any quadrilateral, you can start with any type of quadrilateral, and in this quadrilateral if we join midpoints of its sides, we always get a parallelogram. You can verify this by drawing yourself a quadrilateral and then join midpoints of its sides and check whether it is parallelogram or not. We have to prove this fact using vectors. So let A, B, C, D be quadrilateral, that red colored. J, K, L, M are midpoints of sides. A bar, B bar, C bar, D bar be their position vectors. So here is the figure. A, B, C, D is any type of quadrilateral. J, K, L, M are midpoints of its sides. We have to prove that quadrilateral J, K, L, M is a parallelogram. Now when a quadrilateral is called a parallelogram, एखाद्या चौकोनाला समांतरभुज चौकोन आहे असं आपण केव्हा म्हणतो? किंवा एखादा चौकोन समांतरभुज चौकोन आहे हे कसं सिद्ध करतो? बरोबर आहे. There are several ways. If we prove that opposite sides are parallel to each other, that means if we prove that J is parallel to LM, JM is parallel to LK, that is enough. In both the pairs, if opposite sides are parallel, that is a parallelogram. Second method is if we prove that in both the pairs opposite sides are equal in length, that is also sufficient. Third method is if we prove that in one pair only opposite sides are parallel and equal, that is also sufficient to prove that quadrilateral is a parallelogram. So I will use that method. I will prove that in one pair only opposite sides are parallel and equal also. Okay, so I will use midpoint formula. I have written J bar. It is half of A bar plus B bar. A bar plus B bar upon 2. Similarly, I can write K bar, B bar plus C bar upon 2. L bar, C bar plus D bar upon 2. And M bar is D bar plus A bar upon 2. So here I have written position vectors of all midpoints in terms of endpoints. Then I have obtained LK, this vector. I have obtained this vector LK. ही LK जी बाजू आहे ह्या LK बाजूने रिप्रेझेंट केलेला जो वेक्टर आहे तो मला मिळवायचा आहे. सो फॉर दॅट आय यूज दिस रिझल्ट LK bar is equal to K bar minus L bar, and I have ready-made value of K bar, I have ready-made value of L bar, so I have used those K bar, L bar and simplified it, and I have observed that this is equal to half of dB bar. LK is half of dB, Now I will find MJ. its opposite side. Its opposite side mj bar is also half of dB bar. You can check your calculations. This proves that lk, this vector lk is equal to mj. This is mj, half of dB bar, and lk is half of dB bar. So I can conclude that lk bar is equal to mj bar. This lk bar is equal to mj bar. That means vector represented by lk is equal to vector represented by mj. That means these opposite sides of this parallelogram, they are parallel to each other, and not only this, they are equal in magnitude also. So when opposite sides of a quadrilateral are parallel and equal, that quadrilateral becomes a parallelogram. Therefore, the segment joining midpoints of sides of any quadrilateral is always a parallelogram. So this proves the result. It was little bit lengthy and constructive. Now one more similar type of problem is there. This is also little bit lengthy and constructive. So let us read what the problem says. D and E divides sides BC and CA of triangle ABC in the ratio 2:3 respectively. Find position vector of the point of intersection of AD and BE and the ratio in which this point divides AD and BE. So question is, first information is given. What information is given? This D divides BC in the ratio 2:3. Point E divides CA in the ratio 2:3. And they intersect, they means AD and BE intersect in point P. We are asked to find the position vector of point P and the ratio in which P divides AD and P divides BE also. P हा पॉइंट AD ला कोणत्या रेशो मध्ये डिवाइड तो करतो, BE या सेवियन ला कोणत्या रेशो मध्ये डिवाइड करतो ते आपल्याला शोधायचं. These segments are called savians, not medians. If D is midpoint, then it will become median. But now D is not midpoint, D is just a point on BC, so AD is called savian. These savians meet each other in P, intersect each other in P. We are asked to find position vector of P. So इथे पात्र परिचय करून दिलेला आहे. हे जे पॉइंट जेवढे दिसतात त्या सगळ्यांचे पॉइंटचे पोझिशन वेक्टर कोणत्या अक्षराने डिनोट करायचे ते लिहिलेलं आहे. रेशो 2:3 लिहिलेलं आहे. याचा वापर करून मी D चा पोझिशन वेक्टर लिहू शकतो. आय कॅन राईट पोझिशन वेक्टर ऑफ D इन टर्म्स ऑफ B and C using section formula. So I got this equation 5D bar. This 2 plus 3 is 5. 5 is shifted to this side. 5D bar is equal to 2C bar plus 3B bar. Similarly, I can obtain one relation between E bar, A bar and C bar. So this is one relation, this is one relation. हे एक रिलेशन मिळवलेलं आहे D bar C bar B bar मधलं. D bar C bar B bar. अगदी सिमिलर रिलेशन तुम्हाला E bar A bar आणि C bar मध्ये मिळेल. कारण रेशो तोच आहे. रेशो तोच आहे. कुठे आहे ते रिलेशन? हे काय इथे आहे. हे रिलेशन आलं. 5E bar is equal to 2A bar plus 3C bar. आता हे जे दोन रिलेशन्स आहेत त्याच्यापासून मी असं लिहितोय 2C बार. पहिल्यातून 2C बारची व्हॅल्यू काढतो, दुसऱ्यातून 3C बारची व्हॅल्यू काढतो. म्हणजे हा C बार दोघांमध्ये कॉमन आहे. इकडे BC बार मध्ये C बार आहे, AC मध्ये पण C कॉमन आहे, म्हणून C बार एलिमिनेट करू आपण. वी फाइंड व्हॅल्यू ऑफ C बार and we eliminate it, multiply this first by 3, second by 4 and subtract. So C bar will get eliminated, and after eliminating C we get this relation between D, B, E and A. D, B, E and A. D, B, E and A. We pair A and D. B with E. ह्यांच्या जोड्या लावताना आपण D आणि A ची जोडी लावतो. हा D इकडे आहे, A इकडे आहे. मग A ला इकडे घ्या. A is shifted to this side. E बार आणि B बारची जोडी लावली. E बार आणि B बारची जोडी लावली. पहा आता हे असं चित्र दिसतंय आणि ऑटोमॅटिकली इथं आपल्याला हे पाहायला मिळतंय की 15 + 4 is 19. 10 + 9 is also 19. So I will divide this equation by 19. I write that 19 here as 15 + 4 and this 19 in right side as 10 + 9. So from this I can conclude that this vector is the position vector of that point which divides AD in the ratio 15:4. This is the position vector of the point which divides BE in the ratio 10:9. And this is position vector of point P. This is the position vector of point P. म्हणजे आपल्याला रेशो पण मिळाली, तिन्ही प्रश्नाची उत्तर मिळाली. P पॉइंटचा पोझिशन वेक्टर पण मिळाला. P पॉइंट AD ला कोणत्या रेशोमध्ये डिवाइड करतो ते पण समजलं आणि P पॉइंट BE ला कोणत्या रेशोमध्ये डिवाइड करतं तेही आपल्याला इथं समजलेलं आहे. तर हे सर्व प्रश्नांची उत्तर आपल्याला इथं एका स्ट्रोकमध्ये सिंगल स्ट्रोकमध्ये मिळालेली आहेत. तर अशा पद्धतीने आपण हे व्हेक्टरचे काही ॲप्लिकेशन्स पाहिलेले आहेत. तर हे लेक्चर मी आज इथं संपवतोय. एक्सरसाइजमधले मी तुम्हाला एक 6 प्रॉब्लेम करून दिलेले आहेत. बाकी उर्वरित आणखी काही प्रॉब्लेम्स आहेत एक्सरसाइजमध्ये तुम्ही सॉल्व करावे अशी अपेक्षा आहे. इन द नेक्स्ट लेक्चर आय विल स्टार्ट नेक्स्ट युनिट अँड दॅट इज प्रोडक्ट ऑफ व्हेक्टर्स. तोपर्यंत नमस्कार.